Greetings, ladies and gentlemen. What you see before you here is a DJI battery. This battery no longer functions as we press the button and no lights illuminate. It is a very good chance that this battery has discharged to the point that there is not one single bit of energy left in it to even light the batteries. As a result of this, the BMS board is likely locked. There is no way to the current state of this video that a way to unlock the BMS board. We, however, are going to salvage the cells from these batteries and see how it works. This is my first battery that I have disassembled, so if anything goes majorly wrong, it will not be a loss because this battery is toast. First of all, we remove the screws from the top of the battery. One can easily begin to spread the cover from the battery. So first we're going to remove this cover here. There is a sticky area here, so I am going to use a small amount of heat. This heating iron is way overkill for this, but that is why I have put it on its low setting. And we just very carefully go over this area. It is now warm to the touch, and we will work as quickly as we can to unstick it. The adhesive, so much easier. Really easy. There we are. See? Perfectly intact, not torn to pieces or anything. All you gotta do is provide a little bit of heat to help soften this adhesive here, and you're good to go. Now there's two adhesives along the side here, or actually along the back here, that will just go over, help release it, soften the adhesive, easy. No great efforts at all. Just simply slide this out, making sure to bring the board with it. And now you will look in here, and there's also some protective pads here along the side. The back here, I've also already heated it to allow the stickiness tape to be released from it. So now we are able to very easily remove the pack from the case. We bring out the board is free, and then we carefully bring out our PMS board that we need to detach from here. Okay, here is our battery management board, and here we have a sensor wire. This wire comes from the battery management board, which is up here, or your BMS, and it comes down and goes next to these batteries here. And what that does is it senses the heat of the battery. We wish to remove this. A little bit of heat to soften it. And we want to remove this carefully. See how easy that is? Now this wire is able to be removed from your power management board, your power distribution board here. But the PMS is where this sensor goes to. Alright, we have removed most of the rubber on here. Again, a little heat makes it very easy to do. Let us measure the voltage of what we get from the entire pack here. Red on positive. It's 17 volts. That is quite low for a 6S. We'll see whether these cells can be recovered. Next thing we want to do is remove these balancing wires. So here are the balancing wires here. They go into connectors here, and the wires go down to your power distribution board right here. And as you might be able to see here, this has some kind of coating on here as well. So we're just going to carefully heat it a little bit. And then with a few little gentle persuasions with the plastic spudger, we are able to release the connector from its socket. Here are the wires, the balancing leads, the socket, and the wire, the two power wires. You got your negative and you've got your positive. The next thing we need to do is to cut the power wires, and we will do so separately. We have our negative, and then we have our positive. And we gently pull a board out. We've got our temperature wire here. Set the board aside. Here we have our power cables and our balancing leads. Let us test to see what voltage this battery has. 15 volts. Possibly a cell has failed in this pack. The next step is to tie into this connector, which it's hooked up to each of the cells with this balancing connector here, and then we'll be able to test each cell. We could probably do so up here. We'll see whether we can revive this battery or not. We have successfully been able to do so with this battery here. Soldering an XT60 on, and then a balancing lead connector. soldered our balance leads onto the respective balance wires that go into these batteries, and we have not done anything as far as charging it. We will see what we have to begin with. 22 volts, 22%. Alright, that's the same. That's the second cell. That's the third cell. Ah, the fourth cell. That may be the one that's the issue. And then you got 5. That's way different. So, we will see. We will see if we can nurture this battery back to life. We will charge it. We will drain it. We will check it. We will let it stand for a few days. We will see the health of the cells. We can also check their ohms by using this meter as well to see the health of them. But first we will get them all balanced. Ladies and gentlemen, we have the BMS board here. What we have here in front of you are 2 boards that the batteries died and they are locked out. What you see here is a board specifically taken from a working battery. I removed it. I soldered these balance leads on here, and now what we're going to do is show you on a working battery here, right here. This is where it was, this is the battery in which it was attached to in this case originally. And now what I have done is soldered some balancing leads to the battery. And if you notice here, when we plug this in, the balancing leads, we see some flashes, which is normal. And then we're going to plug our XT60 in here, and we're going to have a fully operational battery with a BMS board. Like I say, this was just paired together in this case right here, and it literally flew my drone, my FPV drone, last weekend. I have reduced the lights here so you can see the onboard LEDs. We will now turn this on. See how it flashes? One press. There, now we turn it on. Here we go. And that's the status of the battery. It is mostly charged. So what I have demonstrated here is by separating the BMS board from the battery and then rehooking them up like this, it is successful. So in conclusion, by separating the BMS board from the battery and doing so carefully by making sure that we cut, when we do so, we cut the balance leads one at a time and the power wires one at a time, and we hook it back up, it is perfectly functioning. Here we are demonstrating how an ordinary LiPo battery, such as this Tinderline 1300 milliamp battery, can hook up to this BMS board. When pressing the lights, it shows the status, as you see blinking there. And now we will turn it on, and it turns on. So technically we should be able to plug this right directly into the FPV drone and we would be in business. However, in order to do so, we must communicate properly with the FPV drone, because in this present setup here, the drone will recognize it does not have its original battery and it will not take off. So there is a board that we have that goes between the communication and the drone to tell it that it is all okay and provides the proper information allowing you to take off with said combination of any ordinary LiPo battery. Alright, so here we are continuing our testing with our perfectly good BMS, and we will now transfer to another another battery. This is a reclaimed cell. It was dead for quite a while. It was bought, I acquired the battery, it was dead, and the BMS is also locked. So I put these connectors on and reclaimed the cells. This is just a connection board, a power distribution board. There's no electronics here. This is not the BMS, this is just a power distribution board. So what we're going to do is disconnect. Yes, dear. Disconnect this, put it aside, and let us connect this to a completely different cell. And then we're going to see if it turns on. Yes, it does. Currently this is mid charge. There we go. And now let us see what we see in the goggles. The controller has connected. All right, we got a picture and we have picture in the goggles. We have connection to our remote. Is what will happen. Even though we have a good board, it will not start up. This is cells, brand new cells constructed for the FPV drone. These are the actual cells that the manufacturers use. I put them together in series, and we are going to see whether this thing will start up. And each cell is 3.8. 22 volts, 0.9 volts. So we're good there. So let's go ahead and plug this in. Plug this in here. Go ahead and plug this in here. Then we do one short tap, long press. There we go. Let us see what the reading is in the goggles. We are connected and we are unable to take off. Again, the error says in here, battery installation error. Even though it's reading correctly, it even reads out the value of the battery, 65% in here. In the goggles, there is a error that says battery installation error and a notification. so I will not be able to take off. Let us go ahead and unplug this. So we have here another cell pack that has this board in place that we have not tested yet. Let's go ahead and plug that in. So in all cases, it will start the drone up, but the question is, will it take off or allow it to take off? We have battery installation error. Once again, it will not allow it to take off. We have demonstrated here that with a good and operational power management board, it will read the status of the batteries in the goggles and it will power up the drone, but it will not allow it to take off because it is not receiving the proper information. Here is a ordinary LiPo battery, 1300 milliamp, and let's go ahead and plug this in. And let's see. Once again, it will power the drone on. And once again, it says battery installed incorrectly, unable to take off. Battery installation error. It will not allow us to take off, no matter what battery we hook up to this board. All right, so we need a solution to this. What are we going to do in order to allow us to hook up ordinary batteries such as this or any one of these other batteries to the FPV drone that will allow us to utilize these batteries? All right, our next step to solving this issue is to gain access to these signal wires between the positive and the negative wire here. Here are two signal wires, and we will be accessing and interdicting between these two wires and feeding the proper information to this board and thus to the drone. So our first step was to remove all the white paste or whatever you call it, insulation from just like that is, only was on here with a little bit of heat and then some careful removing of the items, the paste. We were able to make quick work of it. We are following the instructions that have been included in this process. We are hooking up a breakout board between the signal wire and the battery itself so that the drone will be able to receive the information it is looking for. The first step is now completed, and then we have now soldered to the signal wires coming out of the drone socket here, and this will be going to a breakout board, and this negative and positive will be powering the breakout board. All right, here is our board diagram. We have our positive wire coming from the BMS board to the positive side. We have our negative wire going to the ground right here. This red wire is to the switch. It is soldered onto the side of the switch here and goes to the switch here. Here is our signal wires. We have the two middle pins. They connect to the BMS board, and then the two outer pins connect to the black and the white going to the drone. These can be used by connections, or they can be soldered together like shown here. Alright, we are now heading into our final steps of this operation. What you see before you is the setup that works. We have over here the battery. This can be any battery that hook up. And then we have the BMS board under here. And then we have our air circuit board that communicates with the drone. I will include pictures of this in full detail, but let us see the results. First of all, we will turn it on. Alright, the drone turns on. It is going to connect to our controller. A picture in our goggles. And we do. No longer is there an error that says battery connection error. It reads out the voltage of the battery that we have plugged in here. And it also does so on the LCD here. So now let's see if we can take off. Yes, we can. And we turned it off. Let's try it again. Motor is starting. Says it in the goggles. And we are able to accelerate. And we are able to turn them off. So this has now demonstrated that we can hook up any battery here to this setup and be able to not only power the drone, but be able to take off with it and operate as normal with our DJI remote control. Alright, our next step to this project is that we have 3D printed a battery case. This battery case contains all the cells that we have made for this battery pack. These is the original cells from the DJI battery. They are hooked up in series and have a balance lead as well as a power lead to charge and to utilize the cells. They fit in here in this very nice 3D printed battery case from Aero Circuit. These are copper inset inserts into the plastic, the print, in order for us to screw this on. Here is our modified case. Here we have our modified case. We have our modified board, our circuit board from Aircruiser in here. We have the appropriate buttons here in order to press the button on the board. We have a mini USB-C here, mini USB port here. We have a cover on here at the moment. So in this case is Aircruiser's board, and then we have the PPM, the power management circuit board here, and then we have the socket here that plugs into, the connector that plugs into the socket for the FPV drone. As you can see here, here is the power management circuit board here, the original one. And from there comes these XT60 and this balance lead. Once we have these together, we then put them together here, and we simply screw them together like so. We plug this in, and we plug in our XT60, then we press and hold. Oh, the camera sees this in a rolling shutter. We're going to have to insert some pictures in here. But on here it displays 22 volts. It's preset at 6 cell, and it works very well, as our next video will show. We'll plug this in. Here is our copper insert as well. This is where the lock goes in, so this whole system stays in place. Your adjustments, depending upon what you're looking for. And then we do press this in a long hold, and then it shuts it off. Here is our scale. Here is the DJI battery. It weighs 288 grams. Here is our modified battery, allowing us to use any battery. We have in here the DJI cells, the original DJI cells, they're brand new, along with our modified setup, and the weight of that is 358 grams. Alright, these wires can add some grams of weight as well, which are entirely too long, and I will tend to that. But the concept is sound and it does work.